Welcome to the Rory Academy YouTube channel. We share valuable information about power electronics technology and its emerging applications. We have a great announcement to make. Coming soon, we will launch a platform for power electronics technology-based developers. Introducing the brand new www.roryacademy.com. This will be a first online platform where the design, development, and prototyping of power electronics-based systems and products will be learnt and ideas shared through on-demand courses, webinars, tests and evaluation kits developed and sold, and a forum for the curious minds. All our YouTube subscribers will have access to 1-year free membership, which attracts 10% discount on all products. Remember, think deep, think beautifully. Today, we will take an in-depth look at the structure of the BMW iX3 inverter. Our goal is to explore how this highly integrated drivetrain is assembled and to delve into its key components, which play a vital role in the vehicle's performance and efficiency. We'll uncover the intricate design and technology that make the BMW iX3 a remarkable electric vehicle. The BMW iX3 is the electric version of the popular BMW X3, offering excellent refinement and an impressive range between charges. It is equipped with an 80 kilowatt-hour battery, providing up to 279 miles of range. The single-speed automatic transmission ensures a smooth driving experience, whether the vehicle is quietly navigating through traffic or maneuvering along a hilly B-road. Additionally, it can be charged to 80% in just 34 minutes using a 150 kilowatt charger. The BMW iX3 features a central charging unit with 150 kilowatts for direct current, DC, and 11 kilowatts for alternating current, AC, allowing for both types of charging via different plugs. Its drivetrain includes an electric motor, power electronics, and a transmission system housed together. The electric motor produces 210 kilowatts, or 286 horsepower, and is designed without rare earth materials. With a net energy capacity of 74 kilowatt-hours, the battery provides a range of over 440 kilometers and consists of 10 modules with 188 prismatic cells. The highly integrated drive unit combines electric motor, transmission, and power electronics in an aluminum housing. The BMW iX3's electric motor produces 210 kilowatts, which is 286 horsepower, and 400 Newton-meter of torque. The BMW iX3 has a single-speed automatic transmission and a 210 kilowatt inverter operating at 400 volts. A thorough analysis of the highly integrated drive unit indicates that both the shaft casing and the bearing shield are fabricated from aluminum. Additionally, the design of the three-phase AC synchronous motor incorporates brushes and a commutator to supply power to the rotor windings, with the stator and rotor windings shown. Both the motor and inverter housing are made of aluminum. The inverter is connected to the stator winding of the electric motor. The gear with single-speed automatic transmission with a fixed ratio is shown. The first component of the structure is the inverter housing, which is crafted from durable aluminum. This lightweight yet sturdy material provides excellent protection for the internal components, ensuring efficient operation and longevity. The sleek design not only enhances its aesthetic appeal, but also contributes to effective heat dissipation, maintaining optimal performance. The control board, located under the top cover of the inverter, manages the unit's operations. Placing it under the cover protects it from the environment while enabling easy maintenance access. The control board circuitry shape is illustrated. The control board is a crucial component, primarily featuring the gate driver circuit, which is equipped with 6 gate drivers, each one specifically designed for a half-bridge that manages the operation of 2 insulated gate bipolar transistors, IGBTs. Alongside these drivers, the board also incorporates the circuitry necessary for the auxiliary motor drive, enabling additional functionality. This control board is strategically positioned on top of the power module and connects seamlessly to the three-phase AC terminals, ensuring efficient communication and control of the overall system. The DC-link capacitor is a dry type filled with resin and contains two modules, a larger one for the inverter and a smaller one for the auxiliary power converter. It has positive and negative metal terminals for connecting to the power module and terminals for battery connections. The power module is positioned directly above the capacitor bank and directly underneath the control board, as depicted in the illustration. This arrangement ensures optimal functionality and accessibility for maintenance and monitoring. The AC terminals serve as the connection points that link the three-phase output of the inverter to the stator of the electric motor, enabling efficient transfer of electrical energy for motor operation. The cores surrounding each output busbar measure the current flowing through each phase. Let's delve into the details of the power module used in the inverter. This module is designed to handle three phases and can manage a substantial current of 1200 amperes at a voltage of 750 volts. It features reverse conduction technology, utilizing insulated gate bipolar transistors, IGBTs, to ensure efficient operation and reliable performance in various power applications. The input DC terminals of the power module are highlighted with the three output AC terminals of the power module. The assembly of the power module to its coolant jacket is of interest because no bolts were used. Instead, an adhesive was utilized. In addition, the power module is molded using epoxy, making it impossible to check the switches used. Epoxy has many advantages over commonly used silicone gel, such as better heat conductivity. However, they could be too rigid and cause issues due to thermal expansion. Thanks so much for watching. In the next series, we will compare the features of the inverter structure in Tesla and BMW EVs. Remember to like, subscribe, and hit the notification bell. Thanks for your support.